Hello students, welcome to SV Technology. In this video, I am going to explain very important question in COA subject, which is instruction cycle. If you are watching my channel for the first time, please do subscribe and support me. Coming to the topic, instruction cycle. This is the very important topic in COA subject B.Tech. We know that what is a program? A program is a set of instructions, right? An instruction is the combination of micro operations. So whenever we have given an instruction from the starting onwards, by executing it, what is the process going to be happen will be explained in instruction cycle. A program residing in the memory unit of a computer consists of a sequence of instructions. As I said, a program is combination of a set of instructions. These instructions are executed by the processor through a cycle for each instruction. So this instruction cycle will be repeated for each instruction. Suppose a program have 10 instructions, then this instruction cycle is going to perform 10 repeated times. The instruction cycle helps the CPU to perform its programming job of task. This instruction cycle has mainly 4 phases, or we call it 4 stages. The first stage is called as fetch cycle or fetch instruction from memory. So I will explain everything clearly what happens in fetch. Okay. Before going to that, the second phase will be decode phase or decode the instruction, and the third phase will be optional, read the effective address from memory. So this will be do if it is necessary only. Otherwise we don't do this third operation or third stage. We directly go to execute the instruction. So here, as I said, instruction cycle has mainly 4 cycles. So instruction cycle, the first cycle is fetch the information from memory, which is called as fetch cycle, and the second phase is called as decode the instruction, is called as decode cycle, and the third cycle, execute the instruction, is called execution cycle. The third one, which is extracting effective address, is optional. If it is necessary we do, otherwise we don't do that one. So I will explain when we have to do that one or when we don't have to do that one. So after 4th phase, in every instruction it goes again back to step 1, executes the next instruction. Suppose in a program I have totally 10 lines of code. First line, second line, third line, fourth line, like this 10 lines of code. The program starts at instruction 1 and starts with fetch phase, and it completes decoding and execution phase of this first instruction. After completing that, it goes again to second instruction and starts with fetch phase. Okay, every time we have to start with fetch phase only. So here I am going to explain everything clearly. So we go to first phase of the instruction cycle, which is called fetch phase. Okay, so this is the block diagram of our fetch phase. So this is a simple fetch phase. Here in this fetch phase or fetch cycle retrieves the instruction from memory and loads the information into the process instruction register. So whatever you have written program, right, that program is going to stored in memory. Okay, so this fetch cycle what does? From the memory it takes the data and sends to IR. What is IR? Instruction register. Whatever the data is there in memory is loaded into processor's instruction register. So you know that what is instruction register? Instruction register is a register which stores the current executing instruction. So which is of 16-bit length. Okay, 16-bit length instruction register stores the first instruction of which is going to execute currently. Okay, fetch cycle takes that from the memory and loads into instruction register. Okay, it's very clear. Now what we are going to do, what the fetch cycle is going to do, whenever I store the data in IR, it indicates that we have to execute currently. Okay, now the register transfer statements for each fetch cycle is T0, AR, PC, PC to AR. Whatever the content in PC is sent to address register, and at the time of T1 it will be sent to memory address register to AR2 IR. This is what happens in fetch cycle, and program counter will be incremented to PC plus 1. Next instruction address will be stored in program counter. These are the three operations are going to be performed in fetch cycle. What is the first operation we are going to perform at the time T0? Whatever the content in PC will be transferred to address register, and whatever the address, if you go to that address you will find some data or information that will be transferred to instruction register. So now we have to execute that one, and the PC will be counted, means plus 1 for next instruction. Okay, these are the three things going to be happen in this particular fetch cycle. Now the data is in instruction register. Okay, instruction register, which is the length of 16-bit. Now you know that just now I said at the time of T0 what is going to be happen, the contents of PC are placed into AR. Okay, the contents of PC are placed into AR, and it enables the common bus. So this AR whenever the content is in AR, it enables the common bus. This common bus will be enabled, okay, to transfer data from one end to another end. A common bus will work, right? So thus that common bus will be enabled by setting S0, S1, S2. So this S0, S1, S2 to 0, 1, 0. What is mean by this 0, 1, 0? So if the S0 is 0 and S1 is 0 and S1 is 1 and S2 is 0, means the bus is enabled and ready to transfer the data from one place to another place. Ready to transfer the data from one place to another place. Now the content of the common bus transferred to AR by enabling its LD input. So if you go to that block diagram, whenever LD input is enabled, it is ready to take the data from PC. What I said, at the T0 time, what I have to do, I have to send the data from PC to AR. This will happen when this load is enabled. When this will be enabled, this will be enabled when the bus is enabled. When the bus will be enabled, S0, S1, S2 is selected inputs is 0, 1, 0. It is very clear. Now AR is loaded with the content which is stored in PC. So now at time T0 is completed. Now at time T1 what has to happen, which is in memory of address register, should be sent to instruction register. Okay, IR. So why? Because whatever you want to execute, that should be in instruction register. So this will happen when S0, S1, S2 is 1, 1, 1. Whenever the S0, S1, S2 is 1, 1, 1, at the time of T2, the memory of address register, the contents which are in memory address register will be transferred to instruction register and ready to execute. Okay, the contents of command bus are transferred to IR by enabling its LD. So now the operation 2, which is my operation 2. What is my operation 2? The MAR, the memory address register contents will be sent to IR at T1 when the common bus is, which is S0, S1, S2 is 111. It will be enabled and the input of IR, which is LD, is on. Okay, now what happens? Next statement will happen. The PC will be incremented with PC plus 1. So this is where the contents of memory or the contents which the user have written are fetched with instruction register. This cycle is called as fetch cycle. Okay, this is the first phase of our instruction cycle. Now we will see our second stage or second phase of our instruction cycle, which is decode cycle. Now whatever the information is in IR, so what I said, IR means instruction register. It can store 16 bits of memory, right? So now these 16 bits are divided into 3 parts. Okay, like this: 0 to 11 bits is one part, and 12 to 14 bits is second part, and last bit is 15th bit, which is called indirect bit I, and 12 to 14 bits are called opcode, and the first 0 to 11 bits are called address field. So now the instruction register is going to be divided into 3 parts: the first part and the second part and the third part I have given clearly. So now in decode cycle, what happens, I am going to explain. So this cycle decodes the instruction to determine what operation it represents and what operation it requires. So through this decode, I will define what is the operation is going to perform on this particular data, which is stored in instruction register, which is stored in memory, or which is written by the user. The decode cycle is important for the processor for understand what it needs to do with the instruction and what data needs to be retrieved or manipulated. So as I said, T0 time is completed and T1 time is completed. Now at the time of T2, the entire instruction is going to be decoded. So what is the decode instruction set we are going to write here? That is at the time of T2. At the time of T0, what happened? Which is in program counter is transferred to address register. Okay. At the T1 time, what happens? What is memory of AR is transferred to IR instruction register and program counter is increased with 1. Now at the time of T2, the entire instruction is going to be decoded with T2 time. What are the decoded thing we have? So total 3 bits we have for decoding opcode. So opcode is which is of 12, 13, 14. Total 3 bits are divided into 8 operations. Why? Because 2 power 3. In last class we have discussed about that. And we have given these 8 operations as D0 to D7. Okay, D1, D2, D3, D7 up to. So that is D0 to D7 operations will be decoded, and whatever the contents are in address field of instruction register. As I said, instruction register is divided into 3 parts, right? So the first part is address field, right? So which it will be transferred to address. Okay, what is our address? AR. Okay, whatever the instruction register 0 to 11 bits, which are called totally 12 bits, are transferred to address register of the particular processor. And next what happen? Indirect bit, which is indirect bit of IR is transferred to indirect bit. It defines whether the operation is direct addressing mode or indirect addressing mode. So this is what going to be happen in the decode cycle. Next we will discuss about execution cycle. So now how the instruction cycle happened, and we have seen how the decode cycle is happened. Now we are going to see how the execution is going to be happen in this particular situation. So here I am explaining everything clearly. It is started here. When the thing is started, whatever the content is in PC will be transferred to AR. Okay, from AR, okay, which is in the memory of AR, will be transferred to IR. This happens at T0 time, this happens at T1 time, and at T1 time what happens, whenever the memory of address register is transferred to IR, program counter will be incremented with 1. Okay, next what happens, this is total called fetching cycle. Now in decode cycle what happened, the bits of instruction register bits 0 to 11 bits, total 12 bits will be transferred to address register. Okay, and the instruction register 15th bit transferred to the bit I. Now if the decoded item is D7, so what is mean by D7? So D7 means the opcode bit, okay, which is 12, 13, 14 bit is 111. What is mean by 111? 7. So if it is D7, okay, so which is I am going to explain here clearly. If it is D7, so what happens, if it is D7, it is going to perform some operation, right? So if it is D7, so total 4 bits including I bit, the opcode is 1111 and indirect bit is 0. Then it is called as memory reference instruction. So what are the memory reference instructions we have? Total 7 memory reference instructions we have, which we have discussed in last class. So in memory reference instructions also, okay, in memory reference instruction also, if I bit is 0, it is direct addressing memory, and if I bit is 1, it is indirect addressing memory. And if D7 is 1, okay, so if D7 is 1, what happens? If D7 is 1 and I bit is 0, it is register reference instruction, which we have 12 instructions totally. And if it is 1, means D7 is 1 and I is 1, then it is input output instruction, which we have 6 instructions. After completing these instructions, 1 minute, after deciding these instructions at T3 time, if it is memory reference instruction with direct addressing mode, it goes to execute the memory reference instruction and sequence counter will become 0. And if it is memory reference with indirect addressing mode, it will go to effective address. In that effective address you will find operand, it is going to execute the instruction. Otherwise, if D7 is 1 and I is 0, then it is register reference instruction. After performing register reference instruction, SC means sequence counter will become 0. And if D7 is 1 and I bit is 1, then it is input output reference instruction. After executing input output instruction at the time of T3, sequence counter will become 0. So this is how instruction cycle will work for one instruction. The same process will be continued for all the instructions. That's why after completing each and every instruction, the control goes again to the start. So this is how the instruction cycle works. Okay, here you have to remember clearly this table. Okay, this one is very important. So the IR register is divided into three parts, which is 0 to 11 and 12 to 14 and 15th bit. So the opcode is gone through 3/8 decoder and given 8 outputs, which are D7 to D0. If D7 is 0 and I bit is 0, it is memory reference instruction with direct addressing mode. If D7 is 0 and I bit is 1, it is memory reference with indirect addressing mode. If D7 is 1 and I bit is 0, it is register reference instruction. If D7 is 1 and I also 1, it is input output instruction. So total memory reference instructions are 7 and register reference instructions are 12 and input output instructions are 6. In last class we have discussed about types of instruction, memory and register reference, input output instructions we have clearly discussed. Please see that video in this playlist only. So this is all about instruction cycle. In next class I am going to discuss about interrupt cycle. So please do subscribe to my channel and support me. If you want this class notes, please subscribe my channel and send it to my WhatsApp screenshot. I will send the total 5 units PDF of COE.